which give us 22.5 meters. The total area is now equal to 37.5 plus 900 for part B plus 22.5 for part C, which will now give us 960 meters. Question 7. A tugboat is traveling from Asaba to Onitsha, crossing the river Nile with a resultant velocity of 20 knots. If the river flows at 12 knots, calculate the direction of motion of the boat relative to the direction of water flow. Solution. The boats have already made an angle of theta from figure 150 example, which are forming a right angle triangle having the hypotenuse to be 20 knots and the adjacent and the opposite to be 12 knots. We have that from the law of trigonometry, cos theta is equal to adjacent over hypotenuse, which is cos theta, which is 12 over 20, which will give us 0.6000. Therefore, to get theta, the cos inverse of 0.6000 will now give us 53.13 degrees. Example 8. In a figure 1.51, in the diagram figure 1.59, calculate the value of vertically suspended weight W and the angle S. Solution. The forces are resolved as shown below. This will now form a right angle triangle at an angle X, having the hypotenuse 5 kg F and a opposite of 3 kg F with the base of W. Figure 1, which resultant at right angle is now equals to 5 squared is equal to W squared plus 3 squared, which is Pythagoras theorem. The square root of the hypotenuse is equal to the sum of the square root of the other two sides. Then, making the W the subject of the formula, which is the unknown, we now bring 3 to the other side to give us 5 squared minus 3 squared equal to W squared, which will now give us 16 equal to W squared. Therefore, the W will now be the square root of 16, which will give us 4 kg F. Also, S, according to the law of trigonometry, tan S is equal to opposite over the base, which is 3 over 4, which will give us 0.375. Then getting the tan inverse of 0.75 will give us 36.9 degrees. Question 9. A body falls freely under gravity G equal to 9.8 meters per second squared from a height of 40 meters on the top of platform 0.8 meter above the ground. Calculate its velocity on reaching the ground, reaching the platform. Solution. Distance traveled by the body equals to 40 minus 0.8, which is equal to 39.2 meters. Acceleration due to gravity G is equal to 9.8 meters per second squared. The final velocity V is equal to 0. From the third law of equation of motion, V squared is equal to U squared plus 2GS. Since the body is falling from a height, U squared is equal to 2 minus there is the negative gravity times G times 2GS. Substituting the values, we have that U squared is equal to 0 minus 2 times 9.8 times 39.2, which give us 768.3. Therefore, the u, since we are looking for the value of u, the u will now be cross over the square root, which is the square root of 768.3, which give us 27.7 meters per second. Question 10. The hatch door of a submarine has an area of 0.5 meters squared. The specific gravity of seawater is 1.03. Assuming that acceleration due to gravity G is equal to 10 meters per second squared, and neglecting the atmospheric pressure, water is force exerted by the seawater on the hatch door at depth of 200 meters. Solution. Area A is equal to 0.5 meters squared. Specific gravity Sg of the seawater is 1.03. Depth H of hatch door in water is 200 meters. Force F is equal to pressure P times area. Force is equal to PA. But pressure is equal to H density gravity, that is height times density times acceleration due to gravity. Therefore, force F is equal to height times density times acceleration due to gravity times area. Therefore, the force now become equal to 200 times 1.3 times 10 times 0.5, which give us 1030 Newton, or 1.03 times 10 raised to power 3 Newton. Question 11. A mango fruit dropped from a branch 10 meters above the ground. Calculate the velocity just before it hits the ground. Taking acceleration due to gravity to be 10 meters per second squared. Solution. S, this is the distance, is equal to 10 meters. Acceleration due to gravity G is equal to 10 meters per second squared. And the initial velocity, which is u, goes to 0. Since the body is initially at rest, from the third law of equation of motion, we have that v squared is equal to u squared plus 2gs. V squared, which is the final velocity, is equal to initial velocity, which is 0, plus 2 times 10, which is the acceleration due to gravity, times 10, which is this distance. Then the v squared will now become 200. V is now equal to square root of 200, which gives us 100 times square root of 2. V is now equal to square root of 100 is 10 times square root of 2 meters per second. Question 12. A train has an initial velocity of 44 meters per second and an acceleration of minus 4 meters per second. Calculate its velocity after 10 seconds. Solution. U is equal to 44 meters per second. A, acceleration, which is equal to minus 4 meters per second squared. T is equal to 10 seconds. V is equal to unknown. From the initial equation of motion, the first equation of motion, we have that V is equal to U plus AT. Therefore, V, that is the final velocity, is equal to 44, that is the initial velocity, plus minus 4 times 10, which is the time, which now gives us 44 minus 40. Therefore, the final velocity is now 4 meters per second. Question 13.